In this video, we will talk about rules for exponents. So there are several different rules for exponents that we are going to use to simplify exponential expressions, but let's start with our basic definition for an exponential or an exponent. So an exponent is just a superscript that means repeated multiplication of the same base. So superscript, super means up or above, and script is just notation. So we have a little number written in the upper right-hand corner of some other base. Now that base could be a number, like in the first example here, you see the base is 2, the exponent is 5. So that means that that base of 2 is being multiplied by itself 5 times. So you see the number 2 is written 5 times, and they're all multiplied together. In this case, you could actually evaluate that, and that gives you 32. But sometimes your base is a variable. So in the next example, you have x to the third power. X could be any real number in this case. We don't know what x is, but we could write it in expanded form as x times x times x. So just another example of a numerical base down here. Remember, your base could be any real number. So in this case, the base is -3, and if that -3 is raised to the 4th power, then you're multiplying -3 times itself 4 times, and that gives you +81. So you have to be really careful when your base is negative, and you'll know your base is negative because the negative will be written inside of parentheses with the exponent outside of the parentheses. So we're going to go through a series of rules that will help us to simplify expressions that contain exponents. In particular, we use these rules when our bases are not numbers. Alright, so for each of the rules, we are going to do a little exploration, then we'll talk about the rule in general and an explanation of that rule. So the first rule is the product rule. So let's see what happens when we are multiplying two exponential expressions with the same base. So here we have x to the 4th and x to the 3rd. So the base is x for both of them. We can start by writing each of those expressions in expanded form. So notice in the parentheses here we have x to the 4th power, and then in the second set of parentheses x to the 3rd power. Now, since multiplication is commutative and associative, we could actually remove the parentheses, and if we wanted, we could change the order of the multiplication as well. But in this case, we're just applying the associative property, removing the parentheses and just writing it as one group. Since it is all multiplication and the base is still x, we can rewrite that in exponential form as x to the 7th power. So instead of taking these two steps in between here, we can go immediately from the product, x to the 4th times x to the 3rd, to the actual value, x to the 7th power. And if we wanted to use a little shortcut, instead of expanding, we would see that the exponents just get added together, because the exponents tell us how many times to write that base, and we're just adding together that number of times for each expression. So in general, the product rule tells us that if we are multiplying a to the mth times a to the nth, that is the same as writing a to the m plus nth power, which really just means that if you are multiplying exponential expressions with the same base, you're going to keep that base and then add the exponents together. Let's take a look at our next rule, which is the quotient rule. So again, we'll go through a little exploration before we talk about the actual rule. So here we're starting with x to the 5th divided by x to the 3rd. So again, writing both of those out in expanded form, we have 5 x's in the numerator, 3 x's in the denominator, and they are all being multiplied together. Now, if this were just thought of as a fraction, we can cancel out common factors in the top and bottom, because whenever you divide something by itself, you get a value of 1. So imagine I'm crossing out 3 pairs of x's here. And every time I cross them out, I'm really dividing. And any time we divide x by itself, x is equal to, or that quotient is equal to 1. So when everything is canceled out here, all we have left is x times x, and in exponential form, that's x to the 2nd power. So we see here that if we were to go directly from the example to the simplified form, all we would have to do would be to subtract the exponent. So that brings us to our quotient rule. If we have a to the mth power divided by a to the nth power, That's the same as writing a to the m minus n power. So we're subtracting the exponents. Notice that is the top exponent minus the bottom. And it's also important to note here that your base can't be 0, because if your base is 0, you end up with a 0 in the denominator, which makes the entire expression undefined. So again, you have the explanation down below. When you're dividing exponential expressions with the same base, so the bases have to be the same, they're both a and a here, you keep that base and then subtract the exponents, and in this case it's top minus bottom. There are some ways that you can do a little shortcut when we start to talk about negative exponents, where you might want to subtract in a different way. But if we're following this rule precisely, it's the top exponent minus the bottom. Okay, so let's move on to our next rule, which is the power rule. So here we have an exponential expression raised to another power. So we're going to explore what happens when we look at x to the fourth raised to the second power. So we're going to think about the exponent on the outside of the parentheses first, the exponent of 2, and the base here would be this expression x to the fourth. Now, using just the definition of an exponent, we would take that base, x to the fourth, and multiply it by itself twice, in this case, because that exponent is 2. But now I can apply the product rule that we had seen before that tells us that if we are multiplying with the same base, we can add the exponents together. So if I keep that base x and add the exponents 4 plus 4, I end up with 8. Now as a shortcut, going from the original expression down to x to the 8th, we might notice that all we would have to do is multiply the exponents by each other. 4 times 2 gives us 8. So the power rule tells us that if you have an exponential expression raised to another power, then you can just multiply those exponents together and write one expression. Sometimes I like to just say power to a power here. When you have a power to a power, you multiply the exponents. Now these are just some other variations on the power rule. So you could have a power of a product. So the base here is some sort of product, and that could have just 2 factors or 3 factors. The factors could have some numbers there as well as variables. Or you could have a power of a quotient, and again, you could have numbers in here. You could have more than just one term in top and bottom. You could have multiple there. So in either case, when you have either a power of a product or a power of a quotient, you can apply the exponent that's outside of the parentheses to each part of the product or of the quotient. So in the product case, instead of a, b raised to the nth power, we can raise a to the nth and then multiply that by b to the nth. In the case of the quotient, instead of a divided by b to the nth power, we could write a to the nth divided by b to the nth. So it just changes the order of the operations. So on the left-hand side of both of these equations, you would do the multiplication or the division first and then apply the exponent. But on the right-hand side, that order switches. So on the right-hand side, we apply the exponent, then multiply, and in this case, we would apply the exponent and then divide. Our next rule is actually one of the results of looking at the quotient rule. So let's talk about the 0 exponent rule. In the exploration, we have x to the 5th divided by x to the 5th. So if we look at this in 2 different ways, we could kind of see what those 2 ways tell us and then draw some conclusions from both of those methods. So in the first part of the exploration, we are just thinking about this in terms of expanding and thinking about how we simplify fractions. So x to the 5th has been expanded in top and bottom, and anytime you have the same quantity in top and bottom of a fraction, the entire fraction is equal to 1. So even without expanding, I might recognize, well, whatever x is, if I raise it to the 5th power, it's going to be the same no matter if I do it on top or do it on the bottom. So this whole fraction is just equal to 1. And you could also think about canceling out common factors like we had done before. Every time you cancel out here, you are dividing, and that quotient is 1. So we would just have 1 times itself 5 times up here, which gives us a value of 1. Now another way to think about this same expression, x to the fifth divided by x to the fifth, is now thinking about the quotient rule that we had before. The quotient rule tells us that we are subtracting the exponents. So if we subtract 5 minus 5, we have 0. So this expression can also be written as x to the 0 power. So we are looking at the same expression in two different ways. The first way we get 1, the second way we get x to the 0. But these are both equal to the same expression in the first place, so therefore x to the 0 has to be equal to 1. And this is true all the time, of course, except for the case where your base is 0. So our general rule for exponents, if you have some base a, and a is any real number here except 0, and you raise it to the power of 0, the result is always 1. And that's kind of remarkable because even if a is a negative number or a is a fraction, you still get a result of 1. The only time this rule doesn't work or doesn't make sense is when the base itself is 0. And one more result of the quotient rule. So here we have an expression x to the fifth divided by x to the eighth. First, we are expanding on top and on bottom. So we have x to the fifth in the numerator, x to the eighth in the denominator. And if we start to cancel out x's here, we have 5 pairs of x's that are canceled out. So we're actually left with a 1 in the numerator and 3 x's in the denominator. So this expression is equal to 1 over x to the third. But applying the quotient rule here, we can subtract the exponents top minus bottom, so 5 minus 8 would give us negative 3. So that expression is also equal to x to the negative third. Therefore, x to the negative third must also be equal to 1 over x to the third. So that brings us to our negative exponent rule. If we have a to the negative nth power, we can rewrite that as an expression with a positive exponent by taking the base and taking the reciprocal, so 1 over a, and raising that base to the positive nth power. This, of course, only works when a is not equal to 0. You could also think about this in terms of raising the entire fraction to the nth power, but 1 to any power is always 1. So we can just write a 1 in the numerator and don't have to write 1 to the nth power. And again, this works for any base a, so a could be a fraction itself. So if a is already a fraction, you're just taking the reciprocal of that base, which just means to flip that base over. The exponent becomes positive. It does not make the base change sign. So if your base was positive, the base will remain positive, it just becomes the reciprocal. If your base was negative, the base remains negative, it just becomes the reciprocal. All right, that concludes our rules for exponents. Please take a look at the examples in your text for some more practice.